This video will show you how to factor using the master product method. The problem we're going to work through is number 2 from those master problems that we had in class. We're going to use, again, master product here. So for master product, it's especially useful when we have a leading coefficient other than 1. And what we're going to do as our first step is always look for a GCF, a greatest common factor. We don't have one in this case. So for master product, we're going to take the first term that we have, that first number, that leading coefficient, and multiply by our last term. So I'm going to have 3 times 10. That gives me 30. And then I'm going to look for factors of 30 that add to positive 17. So the factors I want in this case are 2 and 15. 2 times 15 gives me 30. 2 plus 15 gives me 17. If you don't see your factors right off the bat, that's fine. Then start with your factor list. But once you've got them, here's what we're going to do. We're going to replace this middle term with these two factors that we found. A lot of the steps for master product are very similar to what we do for the box method. So I've got 3n squared plus 2n plus 15n plus 10. Okay. And just like with the box method, since my middle term has an n, these factors get an n as well. Here's where this differs from the box method. Now since I have 4 terms, I'm going to factor by grouping, or factor by parts. So I'm going to look for the GCF, that greatest common factor, for each of these groups. For my first group, my GCF would be n. Both of these have n as a common factor, and that's my greatest common factor, so I'm going to pull that out front. And then I'm left with, if I divide this n out, 3n plus 2. And I'm going to do the same thing for this second group. My greatest common factor would be a positive 5. Oops. And when I factor that 5 out, or divide that 5 out from both terms, I'm left with 3n plus 2. Anytime you factor by grouping, or factor by parts, including when we're using our master product method, we should always get this stuff in parentheses to be the same. So if the stuff in parentheses isn't the same, double check that you did find the greatest common factor and not just a common factor. And also double check that you did correctly divide it out of each piece. So from here, I treat this as if it's one big group, one big piece, just like how we had our pieces up here. And I look for that common factor again. So this time my common factor is that stuff in parentheses, the 3n plus 2. It's a factor for this term and it's a factor for this term. And that's why I want to make sure it's the same as I'm factoring. So that 3n plus 2 is my common factor, my greatest common factor, so that comes out front. And then I'm left with, if I divide this out, an n, and again if I divide this out, and a positive 5. So this would be my final answer for this problem. 3n plus 2 times n plus 5.